Hey guys, so okay, let's minimize this. Okay, so let's have a look at the pointers. So we are on week 6 now of second year of our DT249 course, and we discussed on computer technology 2. We discussed a bit of C, bit of input and output, a bit of pointers, then double pointers, and now we went through to stacks and queues. And now we're actually using double pointers, and we can see how it can be implemented in codes. So I know pointers are kind of simple idea, but it's kind of abstract at the same time, and I think I said that a couple of times, and that's what I still think about them. It's a bit abstract kind of concept that is actually not that abstract if you think about it. It's very simple. It has a set of rules that you just have to memorize or maybe practice. That's the best way to memorize it. And then it kind of makes sense. And it's so much easier to comprehend all the more advanced uses of pointers and double pointers and stacks and queues and whatever. Actually, at the moment, we don't know what is the actual implementation of stacks and queues, but we know what is the implementation of double pointers in stacks and queues, which means we can use double pointers to pass by reference pointers to head and tail of a queue, for example. But anyway, let's focus on, in this video, I want to go through a file that I made for myself to kind of see how pointers work and how the regular variables work and what is their address and what is their value, how the hell it all kind of comes together. So in here is my code, and at the beginning I declare and initialize three variable. Oh, sorry, declare and initialize two variables, and then I just declare another one. Okay, so we have, and that's another kind of interesting piece of, um, I'll see in a second. So anyway, so first I declare and initialize an integer. I give it 89, then we have a character B, and I give it a value of J, and then I just declare a float C, which if you read through, I'll upload, sorry, the that file somewhere on my Google Drive, so you'll have an access to it, so you can read through the comments after or as you go with me. You can always pause the video and just read it and then listen to my explanation, because I know it's kind of messy, that code. It makes absolute sense to me because I made it, and after you watch me going through it, I recommend doing your own kind of code like this. Rewrite mine or do your own, kind of knowing what you know now. It really helps. At the beginning with the pointers, I had no idea what I'm looking at. Then I went from I don't know what I'm looking at to I kind of know what I'm looking at, and then back to no, I lost it. I forgot, and then I'm just like back and forth. And then I made this code here, and I really got the information to set in. So that's how kind of that's my milestone, this one here. Okay, so then we have pointers here. Uh, so first I'm declaring an integer, a pointer to an integer. So that's how you declare it. So I say that's going to be an integer on the other side, and that's going to be a single pointer. So I just have one pointer, and I have a nice picture here of pointers. So that's actually a double pointer, that one here. That is a single pointer. That's just a pointer to an integer. And so let's call them pointer one, pointer two, and variable var. Yeah, so that's the name, kind of like if you look at my code here, this is the name of a variable. Yeah, so in this case we have ptr1, ptr2, and var. Okay, var is an integer, ptr2 is a pointer to an integer, and ptr1 is a pointer to an integer. And that's it. That's as complicated as it is. There's no crazy stuff. So every time you create a variable, like a simple variable, you say integer, you type integer a equals which means assign whatever 789, this is what happens. It finds some memory in stack, and here is your stack, so that's your memory here, and it finds some memory here in stack, and it puts it in there, and it assigns a value to it. And there's another bit of memory in the stack that remembers that var is associated with this memory. So this is another kind of, it's not a pointer, but it's like piece of information that says if you see in my code var, it means I mean this. Okay. And then if you see ptr2, then I mean this. And if you see this address here, go to that address if I dereference it. So if I dereference ptr2, it's going to give you back the value from here. This is the dereferencing. Yes, you can, if you have double pointer, if you dereference this value, this kind of address, it goes to that address and gives you the value from there. If you double dereference, so if you instead of writing asterisk ptr1, you write asterisk asterisk ptr1, you go from that, you take that value, you go to that address, you go again to that, you read this address again, and you go to that. So you do it twice, and then you take the value. Okay, anyway. So this is our so here we declare it's going to be a pointer to an integer, and then we malloc the some memory in heap. In this case, it's going to be a heap, and that's the difference in here. So if we have something that we need just for like bookkeeping, like this here. So for example, whenever you start a function, you run a function, doesn't matter if it's a main function or it's a function in main. So I have one here at the bottom here, and I'm gonna run it here. Every time you do it, the computer knows roughly, don't know even if it's roughly or not, somehow it knows it has to allocate some memory in stack, so you can do your bookkeeping or whatever for that function. But whenever you malloc some memory, so you can point to it, then it's going to be allocated in heap. And you can read about it a bit more. I know it's a bit, I didn't get the whole post in here, but there is a guy asking a question on Stack Overflow. um, there's a couple of questions about heap and stack. I googled that. The post is called "What and Where Are the Stack and Heap?" Okay, if you Google this, then you can find this article, this post, and there is a guy answering in a very kind of approachable way. What is heap? What is stack? Where does it go? What is that used for? How how to make it more efficient? Blah blah blah. I didn't get like 40% of it, so don't worry. At least you get bits and pieces that that we covered already. Okay. If you read about like stuff like blocks, it's just blocks of memory. Yeah. Blah blah blah. Okay, so let's go back here. That video is gonna take a while, but I think it's worth it because it really helped me to understand the pointers. Okay, so we malloced some memory. Inside of this function called malloc, you put in you put the size in bytes. You put the size of the memory you want to allocate in heap. So, and there's a very easy way to do it. You just put size of and a type. So if you put integer, it's going to be an integer. But if it's some structure, if you created a struct, you remember, yeah, it's just a struct that you put in. Let's say it holds inside. It has a couple of fields, couple of member variables, and they could be like 5 integers. So that's gonna give back size of that struct with 5 integers. It's gonna allocate. Oh, sorry, it's gonna give return a size of 5 integers, and then it's gonna malloc, so allocate space for 5 integers. In this case, it's just one. Okay. In here, because we had some space, if you just put in just declared a pointer like this and didn't have this, okay, then it wouldn't work because it would say, where's my memory? I know you want to point at some integer. Fair enough, I know that here, but in here you give me some value. I don't know where to put it. So that's how you kind of say, yeah, point at the integer, and this is where that integer will be. And then you can assign a value. On the other hand, you could do this. Okay, so if you have some value, some integer that you created before, you can take the address of that integer and put it straight into the pointer. So this is a newly created pointer. I just declared it and I assigned an address, because basically a pointer is a variable that stores an address. That's it. That's all the big whoop about pointer. There is a couple of primitive types of types in C. There's char, character, integer, float, double, and these are the primitive of prime. Anyway, these are the data types in C, and the pointer is like another kind of variable that can point to those or some struct or whatever. It's a point. It's a similar kind of concept, but when these guys can hold some numbers and chars, where is it? Char? There should be char. Chars hold numbers as well, and pointers hold numbers. But char goes to ASCII table and checks what is that symbol. What does it mean, that number? Integer is an integer, so it knows exactly. Mm, it's an integer. You know what integer is. Float knows it's a float, and a pointer is a number that represents an address of some other um, variable. It could be a pointer as well. It could be a pointer to a pointer, like in here. It's not a problem. You can have a pointer to a pointer to a pointer to a pointer as many times as you want, as long as it makes sense. I mean, physically, computers let you do it. C lets you do it, but obviously you don't want to make a mess. The simpler, the better, basically. And sometimes you need to use double pointers, and you'll see in a second why. Okay, so here we assigned an address, and that's um, how you that's the address of A, basically. Denote, sorry for my English, that it's an address of A. Whatever, if I put an address instead of A, I put CC in here, that would give back an address of that variable, which is a pointer, but it still needs an address. And then this is another kind of, okay. So let's have a look at the pointers with the memory. So when you write this, this line of code, so int asterisk cc, so we declare a pointer to an int, and on the right side we malloc some memory, and then we assign to that memory, so we dereference, and that's this, and this is slightly different. Here we say let's make a pointer, and in here we say let's go to that address and assign 10, or let's go to that address and take whatever the value is there. So in this case we assign. Okay, so let's have a look at this, and whenever I say okay, int asterisk cc, I go to stack and I create a little piece of I allocate, and that's that. I don't do it. The computer does it. I don't have to say computer do it, because it's like the most simple thing it does. It finds a piece of memory, the next free, and it's called stack because it goes like this. Whatever is on this layer will go first, will be freed first. So it goes up and down like this. Heap is a bit more messy. It can be allocated in here, but it can be freed in here. So there's no order for heap, and for stack it goes up and down. So anyway, it finds a bit of memory, and it puts CC in there, and it says when you malloc, it says okay, Let's find some memory here. Let's take the address of it and put in there. Okay, so we have CC in here, and the value that it points to, the integer, is actually somewhere in the heap, and it's allocated, and it has to be freed after. Yeah, stack gets freed every time you finish with the function. When it comes to heap, if you don't free it, it's kind of allocated, and it doesn't allow the other the to use it. So you have to free it. Okay, so but anyway, this is the pointer. So you have a pointer here, CC. It's a little uh, it holds an address of something that is allocated here. But also, if you have this kind of pointer, this one here, that actually has A that was allocated in stack. It wasn't mallocked, so it has been allocated in stack. And we have DD, which is in stack as well. Okay, so if we go in here again, we created A somewhere here, and then we created DD and assigned the address of A. Okay, so we stayed in stack. Okay, then we have character, so it's a pointer to a character. We mallocked a bit of memory that will hold a character, and we said, okay, dereference EE, so go to that address and put in J in there. Put in whatever is in B in there, okay? And that's it. And then we create char star string. Well, I call this string. It doesn't have to be called string. It can be called whatever, A, B, C, D, Z. Uh, this is a string, actually. This is the type. And I know it's kind of silly, but it's the string in C. So basically what it does, and it's explained here, if you put it like this, if you type char star whatever string, assign hello in quotation marks, what it's gonna do, it's gonna create like an array back to back to back to back in the memory. So first it has to find this size of memory, free memory back to back to back for that could store 1, 2, 3, 4, 5, 6 characters. I know it has 5 in here. You can see 5 in here, but it's actually it has to store this. Okay, and um, and in here you can see it stores HELLO and backslash 0, and that is called a null sign, and that how C knows that it's the end of the string. So when you want to pass it in here, string, yeah, I'm passing it like this to where is it? PPC. Where is S? String PP. That should be S. P S, I think. Let's see what's gonna happen. It worked before for some reason. Um, I think it should be S if you want to pass string with no symbols there. But anyway, when we pass it, what C does, it knows it's a pointer to a character, so it assumes, seeing that I did this, I put S in there, and then I put this in there. It goes, okay, so I'm gonna go to that first letter and go check what's the next one, what's the next, oh here, what's the next one, what's the next one, what's the next one, oh, backslash 0, that's the end of the string, grand, okay, and that's how it works. I know it's kind of confusing comparing to Python, which is just like it has string in there, and it just works and it takes care of it, but the thing is, Python has been built on C. Somebody wrote it in C. So it's basically someone who thought, okay, C is a bit cryptic. It's not that hard, but you need to wrap your head around it, and sometimes you don't have to. So let's make it easier. Okay, and then we have arrays. So I read somewhere, and I think Dennis said that at the beginning, that array is a pointer to the first item in its in that array, and it just has to know how many items do we have in that array. Okay, so if that array knows it's an array of integers of size of 2, it will just go and check the first one and the next one, and that's it. It's not going to look for more. It's going to say, no, there are no more if you try to look for the index 0, 1, 2. If you look for 2, it's going to say, no, there's no 2 in there. We have just 0 and 1 because there are 2 items there. Okay, and it's the same here, but in this case, as you can see, it's an array of pointers to an integer. Okay, so it's an array of pointers to an integer, 2 items inside, and we have CC and we have DD, and as you can remember, these are pointers. And I didn't put any asterisks here because they are pointers. I want them to be pointers. I don't want to dereference them. I don't want to go to that address. I don't want to take any values from the address. I want to just see what's in there. And this is an address, and this is an address. Okay, so it's gonna work fine. It knows it's gonna be an array of pointers, and when I pass those pointers, it works fine. It's happy. Okay, and then we want to see what's gonna happen actually with all those little differently declared and initialized and assigned and whatever uh, variables. We want to see what's inside of them. So that's gonna take care of it. It's not as scary as as it might look. TT is tab, okay, 2 tabs. So \t is a tab, \n, you know, is a new line. So it's basically I made it look nice when we run it. It's gonna just look a bit more clear to analyze. Okay, so but basically we're just looking here. So first we look what I did in here. I made a like a table that shows an element, so a variable in here. It should be called variable actually. So A, B, C, 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 D, D, E, E, blah blah, and are they are all those variable here. And then I print them out, whatever value I want to take. Does in this case it's going to be a pointer. Yeah, it's an address. An address is a pointer. Pointer is an address. So first I want to print out an address of variable A, and then I want to see the content, the value of it. So it's going to be a D because it's an integer. Decimal stands for D, I think. I mean, D stands for decimal. And then we look at B, we want to see the address of it, and then the content of it, C, which is character, and it is a character. And then we look at C, and we want to see an address of it, and an address is in here, and then we put in the value of it. And here, there's my little comment that you'll see in a second, and so on. So if you stop in here and you analyze what I wrote in here, you should know what I'm doing in here. String works slightly different. So we have an address of this variable string, which is a pointer to a character, okay? But that pointer has to be stored somewhere. So it has its own address. Then if you pass only this, oh yeah, I know, sorry. So I shouldn't change this. And I'll tell you why. This is a pointer, and you see this and this, they're exactly the same. I'm passing string without an ampersand or an asterisk because it can be C can read it as a pointer or as a string, and I put that in here actually. Sorry, I missed that. So S is in here, and then as I told you before, it's going to read it like this. But if I want to see a pointer, it's gonna give me an address. I know it's crazy. This is the messy kind of confusing stuff about C. So I think you're grasping the idea of an address of a variable, of the content of a variable, and of the dereferenced content of the value that is inside uh, a memory that the pointer points to. Yeah. So if we look here, sorry, I actually skipped that. Let's go to a simple kind of um, pointer. Yeah, so CC is a pointer. We want to see an address of that variable, of that pointer, not the address of the thing that it's pointing to. I just want to see an address of the pointer itself. So that's this one, yeah. And then I want to see another pointer, and that's going to be the value of CC. What is it pointing to, okay? And that's the CC without any symbol here. And then I want to see some digit, some integer. Oh, digit or decimal? Probably digit. Anyway, an integer, and that's how dereferencing works. Yeah, it's going to go to that address inside and give me a value that is inside. And it works the same with the character. EE is a pointer to a character, as you can see in here. That's B, and B in here is J. It's a character, okay? So we have B, that is a character, and we assign B to EE, and that's how we get our pointer to a character. And first we want to see what? A pointer to what? To an address to EE, not B yet. EE first. So the variable there is a pointer. And then we want to see another address, and that's going to be the value that is stored inside of EE, the address that it's pointing to. Okay, and in this case, it's an address of B, by the way, because we assigned B to it. And then we want to see the last thing here, the referenced value, which is a character, and that's going to be the reference value of EE, which is J. Yeah, because we assigned B to. Okay, so that's a simple variable, that's a pointer variable, and that's a string. Here we have an array. Here we look at the array of integers. Here is an array of pointers, and here is an array of, and here is the first item of that array. And we want to see what is the address of that first item, what does it hold, and what is the dereferenced value of that first item in an array of pointers, if you know what I mean. Okay, so we'll see it in a second, and then there's this concept of freeing. So basically, as I said before, as I said before, in stack is being managed by the, I don't know if it's OS or is it C or is it Langware runtime. I don't know yet. I'm not that far. All I know is it's being sorted. If you try to free something from stack, it's gonna give you an error. It can't be done. Stack goes up and down like this. That line kind of moves up and down, but so the computer knows what to do. When it comes to heap, if you allocate something in heap in here and here and here and here and here, and you start moving up and up and up and up, and if you don't free it, it's gonna just move slowly towards stack, and then it's gonna hit it if you don't free it. Yeah, if you have a function that is really is badly designed and it allocates something but it doesn't free it and you loop it for 1,000 times or a billion times, whatever times you need to occupy all the memory, it at some stage it's going to hit the stack. So you need to free the allocated memory. So if you do this, basically, if you use this, make sure you free it after you don't need it anymore. At the end, probably at the end of your function. Otherwise, it stays there somewhere, allocated, and it can't be used anymore. And if you do this, no, sorry, if you do this, that's fine. You don't have to free it. It's gonna get sorted on its own. And that kind of stuff, that free stuff, this here, yeah, when you have to free the memory, it's all sorted by Python and Java. They don't bug you with this. You just do your code and you don't think about it. When in C, when you malloc, when you allocate memory, you need to free it after. And it's a very important thing. So what happens when we're freeing the memory? We'll see in a second. Here's the print of it. Then let's play with our double pointers. What do you think? We're gonna take a break here, so it's not too long. I know it's been like half an hour so I'm gonna stop here and continue in the next video. Cheers.